So take your textbook, Thermal Properties of Matter, page number in the new book. Hello, Thermal Properties of Matter. This graph you have to draw.
I don't know.
Okay, it's actually 10.7 in Thermal Properties of Matter. If it is solved, book 11.7, I think. Give heading anomalous behavior of water. Give heading anomalous behavior of water.
99, 25. 11.
You have to draw figure 10.7 or 11.7 in your book. Those are online, I will share.
A thermal expansion of water.
Yes. Both diagrams you have to write. You have to draw.
Keep doing that. Yes.
Push back.
Back. I'll just take a picture of all my phone. Reddit. Why do you have so much of look, it didn't come.
Okay. This diagram is what you have to draw. Okay.
This didn't come.
Did you draw? Draw anomalous behavior of water.
Okay.
You mean this graph?
Yeah, two graphs. Yes. Both graphs you have to draw. Okay. Eleven point four. Sorry, 11.7. This one. These two diagrams, both you have to draw. In the new book, it will be 10.7. Old book 11.7. Draw, then I will explain.
Yeah. 11.
Finished? Behavior of water. Finish, right?
Yeah.
Hi, Nabil. You have to draw, give heading anomalous behavior of water, and you have to draw these two graphs. Thermal properties of matter chapter. Okay, Nabil. One is temperature volume graph as well as the other one is temperature density graph. Completed? So fast. Finish, right? Yeah, you can copy later. Now write, okay. First point. We have to do two big problems today in calorimeter. So first point. Water contracts on heating. Water. I'll explain. Okay, first you write notes, then I will explain. Water contracts on heating. Water contracts on heating. Good morning. Water contracts on heating from 0 degree to 4 degrees Celsius. Water contracts on heating from 0 degree to 4 degrees Celsius. Water contracts on heating from 0 degree to 4 degrees Celsius. This is called abnormal expansion of water. This is called abnormal expansion of water. This is known as abnormal expansion of water. Okay, got it right? Now listen. See, water contracts on heating from 0 degree to 4 degree. Normally what happens? If you heat something, it will expand. Correct. Plastic and all, if you heat, it will expand. Or normally when you heat water, it turns to vapor. That means it is expanding. Water is expanding. So here what happens from 0 degree to 4 degrees Celsius. 0 degree to 4 degrees Celsius. The water is supposed to expand. Normally when you increase the temperature, ice melt. That is expansion, right? It is expanding. But from 0 degree to 4 degree, it contracts, or water contracts on heating from 0 degree to 4 degree. So this is volume.
Yes. I'm in tuition now. Physics.
Okay. So at 4 degree, from 0 to 4 degree, the volume is decreasing. That means it is contracting. Understood? Okay. So this is known as anomalous expansion of water. It is supposed to expand, but it is not expanding. This is the first graph. Okay. After 4 degree, it expands. So the lowest volume for water is at 4 degree. At 4 degree, water will have the lowest volume. Understood? That is the first point. Clear, right? Okay, write the next point. On cooling, next point, on cooling, below room temperature, on cooling, below room temperature, on cooling, below room temperature, up to 4 degrees Celsius, up to 4 degrees Celsius, density of water increases. Density of water increases. Below 4 degree, below 4 degrees Celsius, density of water decreases. Below 4 degree, density of water decreases. Water has lowest density. water has lowest highest. Water has highest density at 4 degrees Celsius. So what they are saying, on cooling below room temperature up to 4 degrees. So you are decreasing the temperature. You are decreasing the temperature. On cooling, what happens? Density increases. This is density. Density of the water increases. And below 4 degree, if you further decrease the temperature, density decreases. So water will be having highest density at 4 degree. Clear, right? See, you need not study these two sentences exactly, but study the graph. Based on the graph, you can explain properly. It will be difficult to remember the sentence as it is, but graph you can study, and based on the graph, you can explain. If they are asking anomalous expansion, both you can draw and explain. First, you have to explain the temperature. You can explain like on increasing the temperature, the volume decreases, volume of water decreases from 0 degree to 4 degree. At 4 degree, the volume will be lowest. And after 4 degree, volume increases. That is anomalous expansion. Now, on decreasing the temperature from room temperature to 4 degree, density increases. Density is supposed to increase only. When you cool, it solidizes. Solid is having higher density. So it is supposed to increase. But from 4 degree to 0 degree, density is decreasing. Not too much, but slightly it is decreasing. Okay, normally when you freeze, it is supposed to increase the density. Okay, but in case of water below 4 degree, that is from 4 degree to 0 degree, density slightly decreases. This is anomalous behavior. Clear, right? Now there is an application for this that you will study from the textbook. The question will be, you can write the question. Explain. See, before that, have you seen in winter, when it is too much winter, in cold places, the river freezes or pond freezes? You have seen, right? So how it freezes? It freezes from the bottom to top or top to bottom? How it freezes? Huh? Top to bottom it freezes? Huh? Bottom it will be, there will be liquid will be there in the bottom. The top layer will freeze. Then it's actually freezing from top to bottom, not bottom to top. So the question will be, explain the freezing of river from top to bottom. That will be the question. Okay. First I will explain, then we will read the textbook. What happens is, listen. When how the temperature of a substance get reduced? If you keep an ice here, what will happen? It will melt after some time. What's actually happening?
It is absorbing heat from the sun.
It is absorbing heat from the surrounding. Okay, that is how. It is absorbing heat. Ice is at 0 degree. Okay, if you place ice, the room temperature, if it is 20 degree or 27 degree, it will absorb heat from the surrounding and it will melt. That is how it happens. Okay, now during winter season, water will be warmer than the atmosphere. Water temperature will be slightly higher than the atmosphere during winter season. Atmosphere becomes cool. Okay, atmosphere temperature decreases, but water will be slightly warmer than the atmosphere. So from the top layer of water is warmer. From the top layer of water, heat will be given to the atmosphere. Okay, heat exchange takes place. So top layer freezes. Okay, and when it freezes, density increases. When something freezes, density will increase. Okay, when density increases, it will sink. The top layer ice will sink. Again, water will come on the top. That sheet of ice will go down. Then the next layer of water will come. Again, the same process will happen. Okay, exchange of heat happens. From the atmosphere to the atmosphere, the water will exchange heat and that layer will become ice. And as it freezes, what will happen? Density increases and it will go down and the process continues. That is how you can explain water or lakes and rivers freezes from the top. Okay, it's there in the textbook. You can, you just write the question and you write the page number. Okay. The question will be, explain freezing of, explain freezing of lakes, explain freezing of lakes from top to bottom. Page number in the all the textbook, it is 282, page number 282. Mega, in your textbook it is 282. Which of you are looking? Thermal properties.
Yes.
Thermal is not your page number. In Bhavan's textbook, the page number will be 206, I think. Yeah, in Bhavan's textbook 206. Sunrise, which page number? 282. Sunrise also 282. Addis, what is the page number?
Which
This page, what is the page number?
206.
206. Okay. You Sunrise is 282, right? Okay. So you the same graph, the page with the same graph. So above the graph, I will read. Okay. Above the graph, left side, first column, above the graph. This means that the water has maximum density at 4 degrees. So at 4 degree, water has maximum density. So it will sink. That is what is happening. That is the principle used here. At 4 degrees, the water will be having maximum density. It will sink. This property is important for an environment effect for bodies of water such as lakes and ponds freeze the top first. As the lake cools towards 4 degree, water near the surface loses energy to atmosphere, become denser and sink. The warmer, less dense water near the bottom rises. However, once the colder water on the top reaches temperature below 4 degree, it becomes less dense and remains at the surface, where it freezes. If this does not, if water did not have this property, lakes and ponds would freeze from the bottom up, which would destroy the animal and plant life. If the water freezes from bottom up, it will be adversely affecting the life in water, right? Ponds and rivers. So that's it. Clear?
Yeah.
So either they can ask, and this is a theory question. Okay. Now we'll go to the next topic. Clear, right? This is okay? All of you, anomalous behavior. Now, next topic you can write specific heat capacity. Jessica, you know Jessica, anomalous behavior notes? Yeah. Sorry, just write heat capacity, okay, not specific heat. Heat capacity. First the heat capacity, then we will study what is specific heat. After that, you will study molar specific heat. Heat capacity. Heat capacity, capital letter S. You tell me what is heat capacity. You studied in chemistry. What is heat capacity? Yes. You studied, right? It's there in chemistry, right? Heat capacity. Specific heat capacity.
Minimum heat required to change state.
That is latent heat.
Temperature, temperature.
Yeah. What is heat capacity? It is the amount of heat required to raise the temperature of a substance by 1 degree or 1 Kelvin. Okay, if you have a substance, if you want to increase the temperature by 1 degree, the amount of heat is energy, right? Then the amount of heat required is heat capacity. Now, what about specific heat capacity? It is the amount of heat required to raise the temperature of 1 kg substance by 1 degree. Simply to increase the temperature of any substance, we call it as heat capacity. Okay, if it is for 1 kg substance, 1 kilogram substance, if you want to increase the heat, if the amount of heat required to increase the temperature of 1 kilogram of a substance by 1 degree, you call it as specific heat capacity. Now, one more term is there, molar specific heat, Cp, Cv and all. What is molar specific heat? It is the amount of heat required to raise the temperature of 1 mole of a substance. You know what is mole? 1 mole of a substance by 1 degree or 1 Kelvin. Understood? Okay, we'll write all the definitions. So write heat capacity. Heat capacity. It is the amount of heat required. It is the amount of heat required. Heat capacity is capital letter S, okay? It is the amount of heat required to raise the temperature of, it is the amount of heat required to raise the temperature of it is the amount of heat required to raise the temperature of temperature of a substance by 1 degree Celsius or 1 Kelvin. Temperature of a substance by 1 degree Celsius or 1 Kelvin. Done, right? So, what is the symbol for heat? What is the symbol used for heat? Q, delta Q. Temperature is delta T. So, S is equal to delta Q by delta T. And what will be the unit? What is the unit for this one? Heat. Joule. Q.
Joule.
Joule. And what is temperature?
No, temperature.
Kelvin raised to -1. If it is in degree, degree raised to -1. Heat capacity is okay, right? Now next term, specific heat capacity.
Heat capacity is to increase the amount of heat required to raise the temperature of a substance by 1 degree Celsius or 1 degree Kelvin.
1 degree Celsius or 1 Kelvin. That's it.
Oh, okay, okay.
Next is specific heat capacity. Same definition, just add 1 kg of substance. Instead of substance, 1 kg substance. Specific heat capacity, it is the amount of heat required specific heat capacity. It is the amount of heat required to raise the temperature of it is the amount of heat required to raise the temperature of 1 kg substance by 1 kg substance by it's the amount of heat required to raise the temperature of 1 kg substance by 1 degree Celsius or 1 Kelvin. One degree Celsius or 1 Kelvin. So how will you write the formula? Small s is equal to delta Q by M into delta T, where M is the mass of the substance. Here M will be mass of substance. What will be the unit? Joule, kilogram raised to -1, Kelvin raised to -1. Okay. Now next term, molar specific heat capacity. Capital letter C. What do you mean by molar specific heat? It is the amount of heat required to raise the temperature of 1 mole of a substance by 1 degree or 1 Kelvin. Right. It is the amount of heat required It is the amount of heat required to raise the temperature of
One mole of substance.
It is the amount of heat required to raise the temperature of 1 mole of a substance by 1 degree or 1 Kelvin. Formula will be delta Q by N delta T. Unit will be joule. Mole raised to -1. Kelvin raised to -1. That will be the unit. Okay. Finished, right? Okay. Now next is CP and CV. Have you heard? Molar specific heat capacity at constant volume, constant pressure. You have not heard of all these terms? Other batch was knowing all these terms. CP minus CV is equal to R. Only ZR knows all these. CP Mayer's relation, CP minus CV is equal to R, the gas constant.
Oh, this thing in chemistry.
Yeah, that is what I was asking all these time. That's what every year when I teach, already you might have studied all these things in chemistry.
I never teach in school.
Huh?
We didn't teach in school.
Okay. So CP and CV, okay. C is the molar specific heat capacity. If it is for constant volume, you call it as CV. If it is for constant pressure, CP. And there is a relation CP minus CV is equal to R. This derivation is there in chemistry and physics. If you're studying chemistry, it's fine, you can follow that. In physics, we will study the derivation in the next chapter. Okay, you can study any one derivation, either physics or chemistry. Now, you write CV, molar specific heat at constant volume. Molar specific heat capacity at constant volume. Yeah, behind. It's there. So, if you want, you can write the definition. It is the amount of heat required to raise the temperature of 1 mole of this substance by 1 Kelvin at constant volume. Okay, this is applicable for constant volume. Now, CP is molar specific heat capacity at a constant pressure. Molar specific heat capacity at constant pressure. And there is a relation CP minus CV is equal to R. This is known as Mayer's relation. Heard of this?
Yes.
Mayer's relation. Derivation we will study later, next chapter. So as of now, you just need to know this much. Finish, right? Now again, you have to take the textbook, okay?
Yeah.
Hmm? The textbook, table 10.3. In all textbook, table 11.3. There is a table 10.3 or 11.3. Okay, there is a table. Take that. Table 10.3 or 11.3. Yeah, that table. This table. What is the specific capacity of?
No. Just read it instruction.
Okay, you'll read below the table. Water has the highest specific heat capacity compared to other substances. For this reason, water is used as a coolant in automobile radiators. Do you know what is a coolant? What is it?
It's like a special liquid made for cooling engines.
Yeah. Okay. So you will drop this, you will put this coolant to the radiators as well as heater in hot water bags. Why we are using water? Because water is having high specific heat capacity. It's 4186 joule per kg per Kelvin. Compared to all other substances, water is having the highest specific heat capacity. Owing to its high specific heat capacity, water warms up more slowly than land during summer. During summer season, sea will be cooler than land due to this high specific heat capacity.
Why
Consequently,
it's that in winter or in night time it will actually be more hotter.
because atmosphere is much more cooler. That's why. Now, and consequently, wind from the sea has a cooling effect. Now you can tell why desert areas and earth surface warms up quickly during day and cools quickly at night. Okay, so all this is due to the phenomena of high specific heat capacity of water. So that topic is over. Now, advantage of specific heat capacity, if they ask, you have to write this, okay? Water acts as a coolant and it is responsible for this what? Sea breeze and all. Okay. Now next topic, calorimetry. Give heading, calorimetry. Calorimetry. You wrote calorimetry? Okay. See, we will study two problems from calorimetry. That is enough. You should understand and do those two problems. That's it. If anything is coming, it will be based on that only. You can understand these two problems, that is enough. Okay. Basically, calorimeter problems are there. Today we will study that. Then next class we will study latent heat problems. You know what is latent heat? Latent heat. It is a temperature at which ice and water coexist. At 0 degree, water exists in liquid as well as in solid form. And at 100 degree, water exists as solid and gaseous, liquid and gaseous. So latent heat capacity of freezing, latent heat of vaporization. So we have problems based on that. Now calorimetry, we will use specific heat capacity formula and we will find. When it comes to latent heat, we will use specific heat formula as well as latent heat formula we will apply. Okay, then after latent heat problems, we have conduction problem. When heat is conducted from this much, when temperature conducted from this much, this end to this end, what will be the energy transfer, such problems. So three big problems are there: calorimetry, latent heat, and conduction problem. Most important is conduction, then latent heat, then calorimetry. But only if you understand this only, we can do the remaining. So this we will study calorimetry. So basically calorimeter means you have you seen people making this what do you call blacksmith is the one who play with metal, right? Blacksmith, right? Correct only, right? No? Yeah. So have you seen they making axe and all? They will actually heat that metal and they will heat it and put it in a particular shape and they will put the metal in liquid to cool. Okay, so that metal is at a high temperature. When you dip it in water, the water will gain that temperature. Heat transfer is happening. So how much heat transfer? That is what we are going to find here. Okay, so calorimeter is a device used to find that. How much heat is being transferred. Okay, so if a metal ball is heated and if you drop in liquid, how much heat is being transferred? Okay, so basically the heat lost by that metal object will be equal to heat gained by the water. If you're thinking about the blacksmith, he heated a metal object and it attained some particular heat, 10 joule, 100 joule of heat it has. Okay, he dipped it in water and the water temperature increases from 20 degree to 80 degree. Okay, so heat lost by the axe will be equal to heat gained by water because energy can only be transferred. It can neither be created nor be destroyed. Okay, only heat transfer is happening. So for doing calorimeter problem, we have only one equation. Heat lost is equal to heat gained. That is a basic equation. And how will you get that heat from the specific heat equation? S is equal to Q by T, right? So this is the heat lost or gained, which will be equal to specific heat of that material. If it is water, if it is an SI system, you will take 4186. In the table, use of 4186. That is the specific heat of water in SI system. If it is CGS, it is EC, 1. You will take specific heat capacity of water as 1 in CGS. In SI, water will be 4186 joule kilogram raised to minus 1, Kelvin raised to minus 1. This is in SI. If it is in CGS, 1, instead of joule, it will be calorie. 1 calorie, gram raised to minus 1, degree Celsius. Degree or Kelvin doesn't matter, okay. It is okay, interchangeable. Both are okay. Okay. So if it is in CGS, you will take value 1. If it is in SI, you will take 4186. Water specific heat you should know. Normally they might give, but this you can remember. Even if it is not given, you can use. Any other metal, if they are talking about aluminum metal ball, copper metal ball, those specific heat they should be giving. Then only you can do the problem. Okay. So here you will find how much heat is lost. Specific heat of if that axe, if we are talking about the blacksmith, axe specific heat into temperature, initial temperature. That will be the heat. And same like that, how much it is gained by water. Okay, so that is the method. Okay, so we will read from the textbook. Okay, just write few sentences, then we will read the textbook. So calorimetry give heading. Below that you can write. First point, calorimetry means measurement of heat. Calorimetry means measurement of heat. Calorimetry means measurement of heat. Calorimeter is a device used to measure heat. Calorimeter is a device used to measure heat. Calorimeter is a device used to measure heat. Now, principle of calorimeter. Principle. What is the principle? Heat lost is equal to heat gain. That is the principle. So, right. When a hot body and a cold body comes in contact, when a hot body and cold body comes in contact, when a hot body and cold body comes in contact, the heat lost by hot body, the heat lost by hot body the heat lost by hot body is equal to heat gained by cold body. Heat lost by hot body is equal to heat gained by cold body. Heat lost by hot body is equal to heat gained by cold body. Clear, right? Is it okay? We will read from the textbook, okay, how the device is made and all. Below calorimeter, read that paragraph. Below calorimetry, up to example 3, read that. All of you read. Before that, yeah, before. Below the table, okay.
Yeah.
That is the best way. Get things and always a basic temperature. You know, it's a good thing.
Finish.
All the games.
I mean, that's sad. This is the thing that jacket.
Yeah. Dan, can you explain? Okay, Royden, explain calorimeter.
Okay, basically it's used to measure heat.
Okay,
Yeah.
then how is it constructed?
It's like a metallic vessel with a stirrer of the same materials like aluminum or copper.
Okay,
Yeah.
then
There's a wooden jacket too.
wooden jacket.
Yeah.
Okay,
Huh?
To like insulate heat from getting lost. Right.
okay. So calorimeter means measurement of heat. When a body at high temperature is brought in contact with another body at lower temperature, the heat is lost by the hot body is equal to heat gained by the body. A device which is used for measurement can be called as calorimeter. It consists of a metallic vessel and stirrer of same material like copper or aluminum. The vessel is kept inside a wooden jacket, which contain heat insulating material like glass or wool. So glass or wool actually prevents the exchange of heat. The heat should not be lost to the surroundings, right? Then only the measurement will be accurate. The vessel is kept inside a wooden jacket which contain an insulating material like glass or wool, etc. The outer jacket acts as heat shield and reduces the heat loss from the inner vessel. There is an opening in the inner jacket through which the mercury thermometer can be inserted into the calorimeter. So if you are dropping a metal ball, the water temperature will increase. You have to measure the temperature. Then only you will get that T, Q by T, right? That T. Okay, so for that there is a slot in order for placing the thermometer can be inserted into the calorimeter. The following examples. Okay, now I'll give you this example. We will do next. I'll give you a problem. After that, we will do this example. Concept you understood, right? Now let us do one problem. Write the question. 0.2 kg of a metal. 0.2 kg of a metal. 0.2 kilogram of a metal. 0.2 kilogram of a metal is at 150 degrees Celsius. Is at 150. Is at 150 degrees Celsius. Is at 150 degrees Celsius. Is dropped in a copper calorimeter. Is dropped in a copper calorimeter. In bracket of water equivalent. 0.025 kg of water equivalent 0.025 kg containing of water equivalent 0.025 kg in bracket containing. I'll read again. 0.20 kg block of a metal at 150 degrees Celsius is dropped in a copper calorimeter of water equivalent 0.025 kg containing 150 centimeter cube of water containing 150 centimeter cube of water 150 centimeter cube of water at 27 degrees Celsius. At 27 degrees Celsius. Wait. The final temperature is 40 degrees Celsius. The final temperature is 40 degrees Celsius. Compute specific heat capacity of metal. Compute or calculate specific heat capacity of metal? That is the question. Okay, got the question, right? Okay. Now I'll explain this, sir. See, temperature can be either in degrees Celsius or Kelvin. No need to convert. So you have two cases. You have a metal and you have a copper calorimeter. The principle over here is copper calorimeter with water. Don't do anything now, okay? I'll explain and I'll tell you the steps. This is the condition. Okay. Here what you need to find is you need to find the specific heat of metal. Specific heat capacity of metal is what you need to find. So specific heat capacity of metal will be equal to delta Q by M delta T. So this S is what you need to find. Okay. So we know heat lost by metal will be equal to heat gained by calorimeter. That is a formula. Correct. Heat lost by metal is Q. So you can write delta Q is equal to Sm delta T. S is unknown. Mass of the metal is given as how much? 0.2 kg. So mass of the metal is given as 0.2 kg. I will convert it into gram. Always if it is gram and centimeter cube, calculation is easy. But already if it is given in meter cube, don't convert. Keep it in meter cube itself. Okay. So here centimeter cube, so kilogram to gram conversion if you do, water specific heat you need to take it as 1 only. If it is in kilogram and meter cube, you should take 4186. So this problem we will do with 1 and the next problem in the textbook it is with 4186. So you will understand. So 2 kg, it will be how much? 20 gram or 200 gram? 200 gram, right? 200 gram. Now delta T, change in temperature. The metal the temperature was 150 degrees Celsius and the final temperature is 40 degree. When the metal is dropped, the entire system temperature changed to 40 degree. So delta T will be 150 minus 40. And when you calculate temperature, no need to consider negative. It's not final minus initial or initial minus final. It's the difference in temperature. No need to put negative in both cases. You will take the magnitude only, the temperature magnitude only you will take. Okay, so for metal, the change in temperature will be 150 minus 40, 110 degrees Celsius. That's all for metal. Clear? So you will get heat loss will be Sm delta T. Doubt is there? Understood, right? This much is okay. So this much I'll write. So here the condition is what? Heat lost by metal is equal to heat gained by calorimeter is the condition.
Yeah, you can have that. Epic or something.
Okay. Listen. So, the basic principle is heat lost is equal to heat gain. Okay. So heat loss is equal to heat gain. Okay, so first you will find heat lost. So for metals, listen all of you. See, this is not easy. This problem is easy, but the textbook example is little confusing. So for metal, you will write S is equal to delta Q by M delta T, right? So delta Q, the heat loss is delta Q. Heat loss delta Q is equal to SM delta T. So you will write S into M is how much? 200 gram into delta T is 110 degrees Celsius. Keep it equation 1. This is okay, right? This much? See, all this you should show in the side, okay? Mass is 0.2 kg, 200 gram. Delta T is this much.
How is that 150?
Given in the question.
No, it's 27 degrees.
What? Metal at 150. Read the question. We did for metal. Now we have the remaining. It's not over. For water we have to do. This is just for the metal part. Heat is lost by the metal. Then heat is gained by the calorimeter. Calorimeter was initially 27. It becomes 40. So that is the second part. You write up to this. Then I'll explain the second part. This much is okay, right? Write up to this. Finished, right? Okay. Now, finished, right, all of you? Now about heat gain. Listen. So when you're thinking, this is a copper calorimeter. Okay. Inside copper calorimeter, water is there. Okay. So when you find specific heat, when you put specific heat formula, don't write anything now. Okay. So it's a copper calorimeter with water. Copper calorimeter with water. So basically, you know, copper specific heat is different, water specific heat is different. So when you put the formula, it is supposed to be for copper, you will write S is equal to delta Q by M delta T. This is for copper. And for water separately, you have to write S is equal to delta Q by M delta T. This is actually what you have to do. Because copper temperature is becoming 40, water temperature is also becoming 40. Then you will add these two, that is the total heat gain. But in this question, in the textbook example, you are doing like this. But in this question, it's mentioned. No. Hello. Hi. Class ഉണ്ട്. Yeah. Sorry. മോള് മറ്റേ ഇവിടെ അല്ലേ മെറിലാൻഡിലായിരുന്നോ? അങ്ങനെ അറിയില്ല, ഞാനൊന്ന് അന്വേഷിച്ച് നോക്കാം. ഞാനൊന്ന് അന്വേഷിച്ച് നോക്കട്ടെ. ഇല്ല, അതെ. ഞാനൊന്ന് അന്വേഷിച്ച് നോക്കട്ടെ. മനസ്സിലായി. ഓക്കെ ഓക്കെ ഓക്കെ. AP മനസ്സിലായി. അപ്പൊ അവർക്ക് എക്സാം മെയിലായിരിക്കുമല്ലോ വരുന്നത്. ഞാനൊന്ന് നോക്കട്ടെ കേട്ടോ, എന്നിട്ട് ഞാൻ പറയാം. ഞാൻ നോക്കിട്ട് ഞാൻ പറയാം. ഇൻസ്റ്റിറ്റ്യൂട്ട്സ് ഒക്കെ ഉണ്ടെന്ന് തോന്നുന്നു. ഞാനൊന്ന് അന്വേഷിച്ചിട്ട് പറയാം കേട്ടോ. ഓക്കെ. രോഹിത് ആണോ? ഓക്കെ ഓക്കെ. ശരി അല്ല. ഓക്കെ ഓക്കെ. Okay. So listen. So heat loss is equal to heat gain. Here the heat is gained by copper and water. But here in the question, listen. It is dropped into a copper calorimeter of water equivalent 0.025 kg. It's not mass of copper given separately. Copper in terms of water is given. So the whole system we will consider as water only. Only because it is given in the question water equivalent 0.025 kg. Okay. And so for mass of copper, so copper with water equivalent, so mass of copper you will take it as 0.025 kg. Understood?
Yeah.
Okay. So here you will not separately do specific heat of copper, because copper is given in terms of equivalent water. Copper equivalent to water they have given. It's not mass of copper. It is mass of copper equivalent to water. So you don't have to separately do. You will do it as a single slot, considering it to be as water. Okay. The next problem when you do, you will be doing separately. Then you will understand. Okay. So now mass of water. How will you find mass of water? It is given 150 centimeter cube of water. So then mass is equal to density into volume. Density of water is 1. Okay. So 1 gram. So it will be, you will put, it's in CGS, right? So density you will take it as 1 in CGS. So 1 into 150, mass of water will be 1 kg you will take. Okay, 1 you will take. Is it okay? Sorry, not 1, 150. 1 into 150. 150 kg you will take. 150 gram. Sorry, 150 gram you will take. It's in CGS. Understood? Okay. So for heat gain. Now for calorimeter part, right? Now I'll write it here, then I'll write properly. Okay. So for calorimeter, S is equal to delta Q by M delta T. So delta Q will be equal to specific heat of water only you will take. Understood why? Copper equivalent to water is given. So that's why you will take specific heat of water only. Into mass will be what? 0.025 plus 150. 0.025 we put, if you put it in gram, it will be 25 gram, right? 25 plus 150 into what is the change in temperature? Initially it was 27 degree. The calorimeter was initially at 27 degree. When the metal is dropped, the temperature increases to 40 degrees. So 27 minus 40. 13. No minus. Just 13. So into 13. 40 minus 27. Now this is the heat gain. So you will equate heat loss is equal to heat gain. Only SW is unknown. You will, sorry, only S, this is unknown. SW is 1. As I told you in CGS, SW will be 1. Okay, clear? Now this was for metal. Now for calorimeter. For calorimeter, heat is gained. Heat gain delta Q is equal to Sm of copper plus H2O delta T. Specific heat of water only you will take here. 1 into mass of copper is 25 plus 150 into delta T will be 40 minus 27. That will be equation 2. Now, on equating RHS of equation 1 and 2, we know for calorimeter heat lost is equal to heat gain. For calorimeter, heat lost is equal to heat gain. So equate 1 is equal to 2 and find S. Equate the RHS of 1 and 2 and find S, okay? Do, calculate. All values you know, calculate.
That's what I remember. That's what I just said.
Brother, let me see. No. No. Why is this so free? You're not here, right? Yeah. No. Only this one. This one. Yeah. Two fingers only. Don't do that. Why not?
What is the answer?
What's it? Shit.
What is You have to equate the sun. Yes. You have to find S.
20 watts of to normal ST. That's pretty clean.
What's this?
Ma'am, will it be 91 divided by 880?
Calculate and tell me, I don't know.
Yes.
Very big number. So we should find S here. Four, five, five, divided by one.
This is the calculation.
What's this? You know.
How did I get this?
Ma'am, will it be 0.103?
Yes, yes.
Wait, is there a change?
0.103. So this will be 0.103. And the unit of specific heat capacity, this is it will be calorie gram raised to -1 degree Celsius raised to -1. That's it. With 25, 25 is 7 times, 25 is 8 times. Joule, in SI it is joule per kg per Kelvin, right? In CGS it will be like this. Okay, now after those who finish this, try the example in textbook. Yeah.
You don't have to do it. You can't keep it.
Do the problem, okay? Now you need to write the question. That is the third example. The example after calorimeter, this problem. Read the question, try to understand. So here mass of copper is given separately. So you have to take the specific heat of copper also. Specific heat of copper will be given for you, otherwise you won't be able to do.
Yeah, what is this?
Yeah, what's the example? Write it some.
Example 3.
Example 3.
Read the question and do it.
No, I'm gonna do so.
Nabil, are you saying something? Jessica, what happened?
Nothing. Ma'am, they have some mental issue. No, I won't. That is not enough. That is evidence. No, that is one best of
Calm down.
One time.
Yeah. Short of it.
Did you do? Why the pens are falling down?
No answer.
Okay. Spear made of aluminum question, right? Okay. Listen. A spear made of aluminum of 0.047 kg. So the metal is aluminum here. So mass of aluminum is this much. Placed for sufficient time in a vessel containing boiling water so that the spear is at 100 degrees Celsius. So temperature, initial temperature of the metal is 100 degree. After then it is allowed to transform to a 0.14 kg copper calorimeter containing 0.2 kg water. So here copper and water you have to take separately because copper mass is not given as equivalent to water. So mass of copper. Now about the calorimeters. Mass of copper is equal to how much? How much is the mass of copper? 1.14 kg, right? Mass of water is how much? 25 kg, 0.25 kg. 0.25 kg is kept at a temperature of 20 degree. The temperature of water rises. So here the temperature delta T for both of them will be 20 minus 23, 3 degrees Celsius. Here, the change in temperature will be how much? From 100 it becomes 23. 100 minus 23, 77. So here delta T will be 77 degrees. Clear? So heat loss. Q will be equal to S of aluminium M delta T, heat gain. So for heat gain, you will write the heat gained by copper plus heat gained by water, because specific heat capacities you have to do separately. So for copper it will be specific heat of copper into mass of copper into delta T plus specific heat of water into mass of water into delta T. So these two you will equate, 1 and 2 you will equate, that's it. Okay, here what do you need to find? Specific heat of aluminum you need to find. Specific heat of water you should know 4186. And specific heat of copper should be given in the problem. Then only you will be able to do, okay. Specific heat of copper. It's not given, but it should be given. It will be given for you. 386, right?
Yeah, 386.4.
You take it as 386. Okay, when you equate these two, you will get. Understood? Clear? Okay, so specific heat of aluminium into mass is 0.047 into 77 is equal to 386 into 0.14 into 3 plus water 4186 into 0.25 into 3. So only this is unknown. You have to solve. Only this is unknown. So this you can address 3 into 386 plus 0.1 into 0.14. Only this is unknown. Then what is the doubt? If you convert kg to gram, that is also fine. You can convert kilogram to gram. Then do you know a specific heat of copper in calorie? No. So we can't. Water you can take it as 1. But for copper in calorie, we don't know. Understood? Okay. Calculation. Do you understood this problem? See the difference between the two problems. In the previous case, it was much easier because copper was given equivalent of water. So here, instead of water, any other liquid is fine. Method will be the same.
Okay.
Finished? Calculation is there. Yeah, but water you should know. Copper they should be given. They should be giving. Do this remaining calculations. Pranav?
Yeah.
Understood the problem. Calorimeter problem, is it clear all of you? Oh my God, I will give you. I think I'm the wrong answer. What happened?
The other is in answer. I'm not doing the answer. That's my number. It's a 912.30.
You will get it as. Then power, what about power? What is the answer you all are getting? Sandra, this is the example question, okay? Example 3.
Okay, ma'am.
0.911. Yeah, what you got? 912 joule, right? Correct. Specific heat of aluminium will be 911 joule kilogram raised to -1 Kelvin or degree Celsius. This will be the answer you are getting. Kelvin or degree Celsius? Degree Celsius, right? You will get it in Kelvin, okay? It will be in Kelvin raised to -1 because this other specific heat is in Kelvin. Temperature you need not convert to Kelvin, you will get the answer like this. Got it right? Okay. So this is about calorimeter problem. Now next class we will study latent heat and latent heat problem, heat to transfer also. Next class we can finish the chapter. Okay. Okay then. So Tuesday fluid structure test will be there.